Hi guys, Miss Scott here. So in this lesson, we are going to talk about similar right triangles. Before we jump into that, here's your bad joke. What do you call a broken can opener? A can't opener. All right, well, let's jump into the lesson. So section 7.3, what we're going to do is figure out how can you find the length of the altitude to the hypotenuse of a right triangle. So go ahead and pause so you can jot down that essential question. All right, so the lesson talks about a couple of keywords here. Altitude, remember, is the height. So if we have this right triangle down here in theorem 7.5, the height or the altitude to the hypotenuse is this line right here. Okay, so that line would be the height of that right triangle to the hypotenuse. In other words, if the hypotenuse is the base, which in this case it is, that's the altitude that we're referring to. So remember the altitude, that was one of our terms from chapter 5. Okay, so what happens in this situation is that we actually create three similar right triangles. So it might help to kind of draw this out here. We're going to name this triangle. Let's go ahead and call this point here A, this over here B, and this here C. So if we consider the outer triangle as the first right triangle, okay, what we're going to do is actually draw those in the same orientation. So I'm going to just draw this a little bit smaller so I have space. And then the right angle is at A. Above A we have C, and then over here this acute angle is B. Right? The other two triangles that we have are then this medium triangle on the left, which I'm going to make that one blue, and then I'm going to flip it. So again, the right angle is here, and then we have this triangle here, and here's our right angle, and now the right angle, let's call this point here D, so that's at D. Above it is A, and then over here this is angle B. All right, and then lastly, we have this triangle over here would be our third similar triangle. Okay, so again, we're going to flip that so that everything is in the same orientation. That right angle is at point D. Above it, we have side CD is the shortest, and then over here would be point A. All right, so you can see if you redraw the triangles, it's a little bit easier to see which angles go together, and then we could set up proportions to solve for missing side lengths. All right, so that's what we're going to practice doing in our first example. We have this picture of triangle RST, and we are going to sketch the three similar right triangles from the diagram with the same orientation. So again, maybe it helps to do this in three different colors. So I'm going to start with, I always start with the biggest triangle, which is just the outer triangle. And I always like to put the right angle in the lower left. Just kind of makes sense to me to set it up that way. Whoops, so I don't know where my triangle went. Let's try that again. So here we have the right angle is noticed at S, and then above S we have R, and then over here we have T. All right, and then my second triangle, the medium-sized one, is this one on the right-hand side here. So I'm going to do that one in green. Kind of the nice thing there, I don't have to rearrange anything. It's already in the orientation of the first one. So here we have side SW, and over here we have T. And last but not least, we have this little triangle on the left. So our right angle is still at W, and this one we're going to tip over so that RW is on the side. Okay, so the right angle is at W, above it we have R, and then over here we have S. Right, and again, it turns out these three triangles are all similar, okay? So in this theorem above, we would say, for example, triangle A, B, C. So if I do it in that order, A, B, C, that's similar to triangle D, B, A. So again, we do that in the same order, triangle D, B, A, which is similar to D, A, C. All right. So the corresponding angles do have to match up when you're writing your similarity statement. So redrawing the triangles will help us do that. So in part 2, it says to give a 3-part similarity statement using your triangles from example 1. So the first triangle I'm going to call R, S, T. And again, if I do it in that order from R to S to T, for the second triangle, I need to do the same order. So we'll do S, W, T. Okay, and then lastly, the little triangle in the same order would be R, W, S. And we just say those 3 triangles are similar, so we can use that symbol to represent that. All right, so now in the last 2 examples, we're going to throw some side lengths in and see if we can find missing variables and lengths and all that fun stuff. So example 3, I always recommend starting the problem the same way. Draw the 3 triangles separately. If you try to do it without doing this, that's usually where students run into problems. So step 1 is to draw the outer triangle. Okay, so here's the first triangle. Here's the right angle right there. And I don't know how long this side is. I don't know how long the other leg is, but I do know the hypotenuse is 2 plus 8, so that's 10 units long. All right, now let's look at the medium-sized triangle. So I'll do that one in green. And again, we're gonna rotate that or flip it, whatever we need to do to get this in the same orientation. So here's the right angle. I put 8 on the base and Y on the side. And then lastly, we have this little guy on the left-hand side, and there's the right angle. So for this little one, notice the shorter leg is 2 and the longer leg is Y. Now, when you do this, there's always going to be one triangle that you don't know anything about. So in this case, we don't know anything about this red triangle, so we just ignore that one. And then we use these 2 to set up a proportion. So we're going to do Y over 2 equals 8 over Y. Okay, so we're just setting up the corresponding sides. So we can cross multiply here. Y times Y will give us Y squared. 2 times 8 will give us 16. And then we can square root both sides and we get 4 for that length. All right, so not too bad. Let's try one more of those just to finish off this video here. Okay, so again, draw the triangle separately. It's always going to be your first step. And I know this seems like a long process, but if you try to skip this, it does not usually go well. All right, so I'm going to draw these ones with the right angle in the lower right side here. So now this is 4. And this entire side is actually these 2 added together. All right, so this is going to be Z plus 6. Okay, so we just add the Z and the 6 together. Okay, and now we have this triangle, the medium one, right here. So I'm going to flip that so that it is in the same orientation as this first one. So here's the right angle in the lower right, And I only know that one's longer leg is 6, so I don't have a lot of information there. And then lastly, this little one in the corner, here's the right angle. So let's flip that one. So the right angle is in the lower right again. And that one's shorter leg is Z, and its hypotenuse is 4. Okay, so you might notice here, we're not going to use the medium-sized one. We don't know enough about that. So we can use the big triangle and the little triangle to set up a proportion. Let's do this in this color, sure. So I've got Z plus 6 over 4. Those are the hypotenuses can go together. Is equal to 4 over Z. All right, now I'll be honest, solving this one is going to be a little tricky, so just hang in there. We're going to throw a little bit of factoring from Algebra 1, or possibly Algebra 2 if you're taking that right now. So when we cross multiply here, we're going to multiply Z and 6 both by Z. So Z times Z is going to give us Z squared. 6 times Z gives us 6Z, and that equals 4 times 4, which is 16. Now, you may remember this from back in Algebra 1. This is actually going to end up being a quadratic equation. And to solve these, we have to get 0 on one side of the equal sign. So we're going to subtract that 16 over, and we have Z squared plus 6Z minus 16 equals 0. And to help us factor this, what we are trying to find is two numbers that multiply to give us negative 16 and add up to 6. And a lot of times in Algebra 1 we call this the diamond method. Basically we're just trying to figure out what two numbers go in as our factors here. So if you think about this, two numbers that multiply to give us negative 16 and add up to 6 are going to be a negative 2 and a positive 8. Okay, so negative 2 times 8 is negative 16. Negative 2 plus 8 gives us 6. So you multiply to get this number, add the two numbers to get this number. All right, so this is going to turn into Z minus 2 and Z plus 8. And then lastly, to solve these, we're going to set each of these factors here equal to 0. So we'll say Z minus 2 equals 0, and then Z plus 8 equals 0, and then we can solve. So over here, if we add 2, we end up with Z equals 0 plus 2 is 2. Over here, we can subtract 8, and 0 minus 8 cancels over here, and then we get 0 minus 8 is negative 8. Now, only one of these answers actually makes sense. Z is a length. So you can't really have a negative 8 for a length, so technically it's a solution, but in the context of this problem, only 2 is the one that makes sense. All right, so kind of some little bit more challenging algebra in that last example. But for our sake and purposes, if you can do things like example 3 here, which wasn't too bad, you'll be in good shape. All right, if you guys have any questions on any of these examples or any of the problems on the homework, come find me or leave a comment or question down below in the comment section. Okay, we will see you guys next time. Take care.